Hello everyone. In today's class, we'll see another basic thing in network analysis, and of course which is basic for electrical engineering as well. When you say two elements are connected in series, or when you say they're connected in shunt, what is shunt? We normally get confused here whether elements are in series or shunt. And how to simplify a network. Some people says you'll have to simplify from the right side, or if terminals are given this side, you'll have to simplify from this side. Something people says. Let's see what exactly is the point of simplifying. So first, let's see different elements. We know this is a resistance and it has two terminals, and we have another element that is voltage source, active element. It also has two terminals. We know this. So next, let's look into node. What is a node? Node is a meeting point of two or more elements. Node is a meeting point of two or more elements. If you see, I have two elements and they met at this point. So I will call this as a node. But normally we don't represent with these bubbles. We normally represent like this. So it doesn't mean there is no node here. There is a node here. Because two elements are getting connected here, so there is a node here. Yes, this is also a node. This is also a node, because here 1, 2, 3, 4 or 4 elements got connected here. That is also a node. I know those who are preparing for gate, you may get confused between this node and this node. This is called as a simple node. If only two elements got connected, we'll call it as a simple node, but it is a node. If more than two elements got connected, we'll call it as a principal node. But both are nodes. Now what about this circuit? Here, this is a node, and how many elements are connected? It seems to be 1, 2, 3. These 3 elements are connected here. But it is not just 3, 5 elements got connected. This is 1, 2, 3, and 4, and 5. Because in between these also there is no other element. So it is one node. Yes, this is also connected to the same node. Okay. Now here we'll have to know another thing. Degree of the node. We understood what is a node. Now let's see what is the degree of a node. It's very simple. Degree means if the node is having two elements got connected at this node, we'll call the degree of that node is 2. If number of elements are 4 connected to this node, we'll call degree of this node is 4. Here 1, 2, 3, 4, 5. All are connected to the same node. So we'll call the degree of this node is 5. Okay, now let's come to the actual topic. What is series? How do you define series? If a node is having a degree 2, if a node is having a degree 2, we'll call that node as, we'll call those two elements are connected in series. This is the definition. So before we go to the definition, let's look at it. This is a node, and what is the degree of this node? It is 2, because we got two elements connected to here. So degree of the node is 2. So hence I can call these two are in series. And what is the degree of this node? This node and this node is same, because in between there is no element got connected. So degree of this node is, this is and this one both are in series. Degree is 2. So these two are in series. What about these two? They are also in series because they have the same node and the degree of this is 2. So these two are in series. So definition is, if the degree of the node is 2, then the corresponding elements are said to be in series. That is, if node has two elements connected, then those two elements are said to be in series. I think it is clear. Now let's come to the definition of parallel or shunt. We'll normally call it as shunt. Shunt means, the literal meaning of shunt is diversion. So in electrical terms, shunt means diversion of current. So to say elements are in shunt, it has to satisfy two conditions. First condition is, there must be a diversion of current. As the name says, there must be a diversion of current. Second condition, this is not enough. First you'll have to check this, whether there is a diversion of current or not. If you are satisfied with this, you'll have to check second condition, that is, whether these two elements, if you take two elements, whether those two elements are sharing the same node or not. Sharing the same nodes. If these two conditions are satisfied, we can say they are in parallel. So let's check whether these two are in series or parallel, or may not be both. Let's check it. First condition is current diversion. Current is coming from here. Yes, current gets divided. So first condition is satisfied. But it doesn't mean these two are in parallel. We'll have to check second condition as well. If second condition also satisfied, then we can say both are in parallel. Second condition says both are sharing the same node. Let's check it. Yes, this terminal, we have one node. Yes, we have a common node. So these two elements are sharing the same nodes. So as both the conditions are satisfied, I can say these two are in parallel. Now can I say R3 and V2 in parallel? Just check it. R3 and V2. Yes, current is getting divided and they have same nodes. These two, this is same, this is same. They are sharing the same nodes. So they are in parallel. Likewise, these two also, they will be in parallel because both the conditions are satisfied. So that is what shunt or parallel means. They have to satisfy two conditions. One is current divides and both elements should share the same nodes. Now with this, let's try to identify whether they are in series or parallel. Yes, tell me these two. Yeah, they have meeting point here and degree of this node is 2. So these two are in series. These two are in series. Now these two, they're sharing the same nodes. So they're in parallel because current is also dividing. They're sharing the same nodes. They're in parallel. Next, tell me these two, how these two are related. Be careful here. First check whether they're in series or not. These two are to be in series. The degree of this node should be 2, but it is 3. One element got connected, second element got connected, third element got connected. 3 elements got connected here. So these two are not in series. I'm talking about R2 and R1. They are not in series. Are they in parallel? Let's check. Current is getting divided. That's fine. First condition is satisfied. Second condition, whether they are sharing the same node or not. Okay, this node is same for both the elements, but this node here and this node here, they are different. As they are different, I cannot say these two are in parallel. So R1 and R2, they are not in series, not in parallel. I hope things are clear. Now what about these two? Yes, we have a node here. Degree of the node is 2. So these two are in series. Fine. Now what about these two? As it is a simple loop and the degree of the node here is 2, they are in series. It's interesting here. Be focused. What about these two? What about REQ here? Equivalent resistance with respect to this. How do you find it? You see here, we took the same circuit. 4, 4, 6, 6 kilo ohm. Here they are in series because there is no connection here. As we have some connection here, things might be different. You may think, sir, it is open circuit, current will not flow, so I don't have to consider this. But that's not the case. As I'm asking equivalent resistance at these points, which means I mean to ask, what if I connect here a voltage source? What if I connect here voltage source of some known value? How much opposition offered onto this voltage source? So suppose if I apply some voltage, there will be some current. So division of these two will be giving us resistance. So this we have to imagine. So if current flows this way, yes, current gets divided. Because I'm assuming if I connect a battery here, how much is the opposition offered to the battery? So if I connect a battery here, current flows this way, so current gets divided and the degree of the node is now become 3. Degree of the node has become 3. So they are not in series. As current gets divided, first condition of parallel is satisfied. Let's check the second condition. What is second condition? They must share the same nodes. Yes, this has 2 terminals. We have a node here which is common, and this is also, yes, there is no element in between, so it is also same. So they are sharing same nodes. So these two are said to be in parallel. 6 and 4K are in parallel. Now, what about these two? Are they in series? Degree of the node is greater than 2, so they are not in series. Are they in parallel? Let's check. Current gets divided. So first condition satisfied. Let's come to the second condition. What is second condition? Second condition is whether they are sharing the same node or not. At this point, yes, it is same, but this element has different point and this element has different point. Both are not same. So they are not in parallel. They are not in series. They are not in parallel. So I cannot simplify. I cannot apply the simplification between these two directly. What about these two? Yes, they are sharing the same nodes. So they are sharing the same nodes and there is a current division. So they are in parallel. And these two elements, degree of the node is 2, they are in series. I hope now you understood how to say whether the elements are in series or parallel. Now let's see how to simplify a network. If the network is given like this, let me zoom it a bit. This is a network. How to simplify it? I want a resistance across AB. How to simplify this? So here point comes. Where to start? Should I start from this side or should I start from this side or should I start from top? Should I start from bottom? Where from should we start? There is nothing like that. You can start at any point. You can start simplifying by ensuring whether the elements are in series or parallel. If you see these two are in parallel, if you find, I'm not saying they're in parallel, if you find these two are in parallel, simplify those two. If you find these two are in series, in between any circuit, anywhere in the circuit, if you find they're in series, club them. So you may start at any point, but normally people prefer from this way. If it is asked from this way, people prefer from this way, but it doesn't mean we'll have to start from this way. You'll have to check whether they're in series or parallel, anywhere in the circuit. Okay, now let's see. These two are in series because the degree of the node is 2 and these two are in parallel because current gets divided and they have the same node, so they're in parallel. So let's simplify clearly. So as these two are in series, I'm writing 5 plus 15 is 20. Next circuit is as it is, that is 5. And we know these two are in parallel. So resultant is 8 ohms. You can simplify, sir. There is no harm in simplifying in between. But you have to make sure whether they are in series or parallel, that's it. If you are sure enough, you can make it out. Now see, are they in parallel or series? 8 and 12, are they in series? No, they are not in series because the node has a degree more than 2. Are they in parallel? Current gets divided. First condition satisfied, but second condition not satisfied. That is, they are not sharing the same node. So these two are not in parallel. So I cannot simplify these two directly. But if you see these two, yes, these two are in parallel. Okay. So the resultant resistance will be 20 parallel with 5. You will get 20 parallel with 5, you will get 4 by 5 into 5, 4 ohms. You will get 4 ohms. What about these two? They are in series. This 8 and 4 are in series, so the resultant resistance is 12 ohms. And we have another 12 here, another 4 here. Now again, can I say 4 and 12 are in parallel? We cannot say, because of course this has same node. For 4 and 12, this is a common node, but the other node is different. It has a different other node. So I can't say these two are in parallel. Neither in series, because degree is 3, not 2. But these two, yes, they're in parallel. 12 and 12, these two are in parallel. Current gets divided and they have the common node. They are sharing the same nodes. So it is 6 ohms is the equivalent resistance. It is 4 ohms, A terminal, B terminal. Now can I say these two are in series? Check it. Degree of the node is 2. As the degree of the node is 2, I can say they're in series. If they're in series, resultant resistance is simply 10 ohms. 6 plus 4. So this is how you'll have to simplify the network. I hope this has given a clear idea how to simplify the network. And it will be helpful when you are simplifying or when you are calculating Thevenin's equivalent resistance as well. Thank you for watching the lecture. Please subscribe to the channel for more updates. And please share the video with your friends. Thank you.